All right. Well, welcome all. I think we're about 10:01 right now is what I'm seeing. I'm going to give it a little about probably 10:05 if that's okay. And then we'll get things kicked off, do a little introduction, and we'll get things going. And I think it's going to be an outstanding presentation today. We're really excited for some of the wonderful things that Alyssa does and some of the great things that we're really talking about that are relevant today in education, especially in the field of gamification. So we'll give it a couple more minutes and then we'll get things going.
Oh, dear.
All right, I lied. I'm not going to go to all five. We're going to get things going right now. So here we go. I want to thank you all for coming. I'm Jason Bruns. I'm the director of the Minnesota State Engineering Center of Excellence. My partner in crime on here is Melissa as well. She's also with the Engineering Center of Excellence. And if you're not familiar with the Centers of Excellence, we do K-16 outreach for engineering and engineering technology programs across the Min-State system. So we're legislatively funded. So at the end of the day, we're here to work for you and support you, whether it be workforce development, K-12, K-16. We dabble in a little bit of everything. So just know that we're here to help and support you. And this is really one of the activities that we do. We want to bring some new and innovative things into your classroom, stuff that you can use, stuff that you can apply. And I think today's topic is just so pertinent to that gamification and bringing that into the classroom. And to let you all know, really the session title was Building STEM Through Experiences and Play. So in this session, we're going to invite you to explore how hands-on experiences and play can transform STEM education for students from all backgrounds. And we have Alyssa here to join us, and she's the CEO and co-founder of Upper Story. And she's going to demonstrate some really practical strategies for leveraging, engaging, low cost, which is so important, low cost tools and games and classroom resources to develop high level STEM skills with confidence. Again, building that confidence in the young people to want to explore. Through that interaction of activities and expert insights, you're going to learn how to show how to play intentionally and foster essential foundations for engineering, computational thinking, and problem solving, especially when time and resources are limited, which is always an important feature. We know you as educators, you don't have an unlimited budget. So what we try to do is be very methodical about how we share and find some good resources like this. So some of the strategies you're going to learn today, approaches for aligning lessons to Minnesota content standards, techniques for designing and engaging hands-on learning and experiences, practical templates and planning tools for that as well, class ready activities to support creativity, collaboration, and problem solving, and ways to build confidence using industry informed STEM practices. So, thank you. Thank you all for attending. I just want to remind you that this workshop is free and complimentary. We offer up complimentary CEUs. So, in order to get your CEUs, you can go ahead and send me an email. That's jason.bruns@mnsu.edu. Give me a little time because I have to do them one at a time, but just know that I can go ahead and support that, and we'll support your educational growth through that. And then remember, There's bonus giveaways. We all love something for free. 3 attendees will be randomly selected to receive one of Alyssa's award-winning STEM games, Turning Tumble, Spintronics, or Bridge or Bust. So those are one of the randomly selected games that you'll be able to receive, and Alyssa's going to drive that process with that. So again, we're all happy that you're here. CTE educators, instructors, coaches, after school programs, we bring them all and we want them all. So we're glad for you to be part of this whole thing. So let me get a little bit about our speaker today. Enough of me, let's get on to her. So Alyssa Boswell. Alyssa Boswell is a CEO and co-founder of Upper Story, an educational STEM toy company that brings abstract concepts to life through playful experiences. Since 2017, Upper Story has launched internationally recognized products, Turning Tumble and Spintronics, used in over 40 countries and available in 8 languages. What a very clever way to go ahead and approach that, ensuring that we've got all inclusivity into that. Alyssa's background includes a BA and MA in education, classroom teaching, nonprofit education work, and 7 years of experience in entrepreneurship and STEM curriculum development. She's known for her engaging, approachable style. So make sure that you press her on that. Make sure you engage with her on that, and a commitment to empowering educators in any environment. So thank you, Alyssa, and I'll let you take it away. I'll get out of the way.
Thanks so much, Jason. This is great. I appreciated your introduction, and thank you, Melissa, also for having me. I'm excited to be working with the Minnesota State Engineering Center of Excellence, and I'm excited to interface with all of you today. I'm imagining that a lot of you are have figured out how to have somebody else teach your class for a bit, and so thank you for being prepared in that way and giving the chance to give yourself this training opportunity. I think that's impressive. I asked Melissa, I was like, how do people get the time to do this? And she said they figure it out. So thank you for doing that. So we're gonna get started and dive in. So I don't use Teams that often, so I might be a little bit clunky, but I think we should be okay. The company that my husband and I started is Upper Story. And I come from a background of teaching. I actually taught Spanish. That was my what I first did. I taught high school Spanish and middle school Spanish before I worked in the nonprofit educational world. And then now I'm doing this whole thing where most of what I teach is actually STEM education. I teach how computers work, how electronics work. I teach about bridges, how they're built and the physics behind them. I teach stuff about AI. The only thing that I've told somebody I wouldn't teach is they said, do you think you could do a class on forestry? And I said, not yet. I can't do forestry yet, but I don't teach a lot of biology stuff. I do mostly the stuff that's more technical, that is more of our traditional technology and computer science type things. My parents are both teachers. So my mom was a kindergarten teacher for her career, and my dad was a high school science teacher. So I come by my willingness to teach things honestly, and they were a great example for me of how to teach, and I learned a ton from growing up in that kind of environment. The games that we sell, as he said, are Turing Tumble, Spintronics, and Bridge or Bust. We did not design them for the classroom, but it became apparent in 2017 when we had Turing Tumble that it was an excellent fit for a classroom setting. And since then, now we have tons of educators around the world who use the game. In fact, we thought this was going to be kind of a side thing that we did, and now we've sold over 250,000 Turing Tumbles over in the whole world. And we actually came out with our 9th language that Turing Tumble is translated into. Spintronics is a bit behind that, and Bridge or Bust is currently only in English, French, and German. So we're getting caught up with Bridge or Bust since that one just came out this year. Now, the first thing that we are going to talk about is we are going to talk about the idea of hands-on play, and why exactly do we need to have hands-on play for our students in STEM education. Now, I've had the opportunity recently to talk to a lot of STEM leaders, and a lot of them have said, and one of them was pretty adamant about it. She said, "We don't need things in our STEM education classroom. STEM is a mindset." And she said, "I really want teachers to start moving away from the idea that they need things in order to teach STEM." And I chewed on that for a while, and I adamantly disagree with that statement. Of course, I didn't disagree with her, but I thought, what if teachers are walking around and saying literacy is a mindset? We don't actually need books or letters in front of us. We need to have a literacy mindset. Absolutely not. The trick with STEM is that our kids are coming into our classrooms, and unless they have a natural interest in STEM stuff, if they like to touch things, if they like to mess with the things in front of them, if they are naturally inclined to some of those building toys, those kids are going to come in ready to tackle STEM. A lot of our students, because it isn't their natural interest, are coming to us without having some of the fundamental building blocks they need in order to be successful in STEM education. There are a lot of articles out there that talk about how spatial reasoning and spatial ability is a big predictor of success in STEM fields. And let me tell you this, kids are often not let loose on things in the physical realm. We often, parenting these days, often kind of draws kids back from messing with things that are physical. We're very careful with, when do we give our kid a knife to help chop up vegetables? Do we have our kids engaging with helping with the laundry, even doing chores around the house? A lot of our kids are spending most of their time on tablets, doing organized sports, doing organized dance or music, and they are not actually engaging that much in the physical realm. And so their spatial reasoning is not caught up. It's not enough what they need when they finally get into traditional STEM education classes, because they're missing all those building blocks. So here's our schedule for today. We're going to talk about, why do our students need these hands-on STEM experiences? What are the building blocks of STEM? Because there's some like common building blocks that people talk about. We're going to talk about, what does a good STEM activity, toy, video, game look like? What are the qualities of something that you would choose in your classroom to use and that would actually go well for your students? We're going to take a break. I've got 3 breaks built in, and we might take them earlier or later depending on the pacing. Then we're going to go through some STEM activities and products. You can see behind me, I pulled out all of the STEM stuff from our STEM library that we have in our office that we use with educators. Educators around here can come in and borrow these things, and I have done some trainings with them where I've had them use some of them. So some of them I have multiple, like I have like 5 Botleys, but we have this STEM education closet where we try different things, and I try to stay on the knowledgeable end of what is out there for students, not just with our products, but with all STEM education. And then I'm going to overview our games. I have Bridger Bus set up right here, and then we're also going to talk about the other games. And then we're going to talk about drawing out those principles and learning targets. How do we know that our students, when we're giving them this sometimes messy, sometimes chaotic experience of hands-on learning, how are we knowing that they're actually taking something from that fits into the standards or what learning targets we were trying to teach them when we engaged with that product or that activity? So here we go. First of all, why do our students even need hands-on experiences in STEM? And I'm going to kind of go back and forth on sharing my screen and not, because sometimes I think that sharing the screen can be slightly distracting. So here is the thing with doing hands-on activities with STEM. I touched on this. Kids are often not doing those STEM activities at a young age. So we first of all have kids that are behind in terms of what kind of fundamental things do they know in order to be successful. Second thing, why do we need physical activities for them? These concepts are abstract. We're trying to teach kids computer logic. How abstract is that? What is a computer doing? How is that logic working? How are we taking, if you've ever used code.org or Scratch, we're taking our little sprite on the screen and we're having them move 3 paces forward. Then we're having them jump. Then we're having them maybe turn around. And the kids have to be able to say, I can imagine on a screen what this little guy is going to do. And then I'm going to write it in blocks. I'm going to pull blocks over to say what it's going to do. But trying to make that whole, it's going from the your brain, what you want it to do, to this abstract thing on a computer is very hard for them to imagine. The other thing that we struggle with STEM concepts is attaching them to a purpose. So a lot of our students, I am in the Mounds View School District, and we have tons of parents who work at Medtronic and Boston Scientific and some of those tech companies. A lot of our students don't make the connection between their coding and what their parents do for a job. I've talked with lots of kids that say, my mom works on the computer all day. She's a coder. Okay, well, what does that mean? What does she do? I have no idea. It seems really boring. And some of them have gone to work with their parents and they're like, she just sits at a computer all day and she types and she gets stressed out because she can't figure something out. And it's just this, all they're seeing are these lines of code. They're not seeing that maybe mom is coding something that is a medical device that is implanted in somebody. And the thing she's trying to figure out is, how am I going to make this sensor turn on at this time in order to alert something on a phone to do whatever? This is so abstract to the kids. So having that relevancy is one of the reasons we need hands-on activities, because it's pretty easy when you're a kid to look at the teacher that's in front of you and say, I know what that person does because they're in front of me every day and I'm watching them. I know what a police officer does. I know what a firefighter does. There are some occupations that are pretty clear. These tech education things, these tech fields are very unclear. My dad works at a warehouse on logistics and he does it on his computer somehow. We don't know what that is. He's making some kind of conveyor belt go, and the kids just, they don't know. They don't know what that is. So that whole sense of purpose. The other thing is, I don't know how many of you, if you want to raise your hand, that would be awesome. But how many of you have kids that are frustrated with their Chromebooks? People have kids that are frustrated. Are you frustrated with your Chromebook? So a new thing that I think is really relevant is, remember when we were kids and we got to go to the computer lab? Were we excited about it? Yes, we were excited about it. Now, on the flip side, we have these Chromebooks that are laggy. They have some issues. So now kids sometimes associate tech education and computer-related jobs with this frustrating technology they're trying to work with every day. And no hate on the Chromebooks. It's just that they're integral in our education system right now, and they cause frustration, and kids say, I don't want to work on those. I went into a Project Lead the Way classroom last month, and I said to the kids, how many of you think that you would like to walk around a lot in your jobs? And I had a bunch of kids like raise their hands. How many of you would like to sit at a desk for your jobs? Just a couple. How many of you feel positively about using a computer regularly in your jobs? I had one hand of this whole class. They were like, I do not want this to be what I do every day. So I thought that was super interesting. So a lot of kids don't understand too, how are computers linked into most of our jobs that we see, even, dental hygienists, nurses. There's computers that are being used, and the STEM education that we teach really helps them with feeling comfortable learning new computer programs, figuring out some of this stuff. All right, so now we're going to talk about the building blocks of STEM. So I'm going to share again because I want you to see these. We're going to start again. Okay, so what are the building blocks of STEM? So this is a common list. The common list of building blocks of STEM are things like problem solving, critical thinking, creativity, curiosity, logical mathematical skills, engineering design skills. Okay, I have a problem with this list. And the problem that I have with this list is that I think underneath problem solving, we have a whole bunch of building blocks. So to me, problem solving is not a building block, because even within the realm of a problem solving thing, we need to have things like the ability to identify what the problem is, isolate the problem, think of options of how we could maybe approach it from different ways. So I haven't really developed this list very well yet. I think it needs some work, but I have a proposal for a different list of what we need for building blocks of STEM. And these are ones that I came up with. And so it's things like spatial reasoning. As I said, spatial reasoning, huge predictor of STEM skills later on. That ability to understand how things fit together. Hand-eye coordination, cause and effect. We had this truck right here, this truck for Bridge or Bust. This is a wind-up truck. And we sent it out to we had like 10,000 games that were opened in 48 hours, Christmas Eve and Christmas Day. We had 10,000 games open. And we had so many of these trucks break. And everybody said, who emailed us and said the truck broke. They said, we took the truck out of the box and it did not wind up. Well, our team, of course, is messing with the trucks, trying to figure out what came loose, what is wrong with the spring inside. We're predicting that kids are turning the key backward because we did not put an arrow on the truck to show you wind clockwise. So multiple of us in the office grabbed a truck and we attempted to break it by winding it counterclockwise. And we hesitated, right? Because we got a bunch of engineers and people who are pretty handy in our office. None of us could bring ourselves to actually break the truck. And what we realized is that the kids, because they don't use their hands that much, winding it backwards, when they hit that resistance, they just kept going. They were not thinking about cause and effect. They were not thinking, this doesn't seem right, I shouldn't force it, because they don't have that many opportunities to mess with something like that. So now we realized we're putting an arrow on the truck on our next batch. And we have sent out probably, 400 new trucks to people with the recommendation, draw an arrow on it. But cause and effect is one of the building blocks to this stuff. Exploration, I pulled back in curiosity because I think curiosity is something that we need as a building block. And as adults, we have to be careful not to stifle that. We want the kids to be curious and explore. And then physical interaction with materials and just basic motor and environmental skills. How do I interact with my environment, with the things that are in front of me? So these are my proposed building blocks. And I would love to, somebody said curiosity should be the first item on the list. I love that. I have no special talent, but I'm only passionately curious. If you have any other ideas for this list, if you think, oh, take that one off, put more on. Last night as I was falling asleep, I was like, oh, I actually kind of want to change my list now. But this is a working list. I have this as it's a project, so I can move curiosity to the top, and then we can keep going. So I would like to know from you, if you don't mind sharing it in the chat, what one or two of these things do you think is most missing from your students? Are there one or two of these that you think, my students really struggle with some of these things? Any you guys can do anything, or if there's something else that you think of, this is what my students really struggle with when we're doing STEM activities.
Alyssa, I'm going to throw out there onto your building block if I can.
Yeah.
I think what would be nice to have in there is the complementary of a problem-solving cycle.
Oh, sure. Okay.
So then there's a methodical means of evaluating the situation, understanding, and then really it can be that whole effort there. Just like you build games, just like you problem solve the issue with the mechanism. I think having that as a building block or a suitcase that is helps them think about this their process methodically would be a nice addition.
Yeah, that's great. Maybe I need a second slide that just has the cycle. Okay, so I really think this is interesting. They struggle with problem solving. This one, I think it might be the curiosity. It really needs to be nurtured And then somebody else said exploration and willingness to try. It's okay not to get it right. And they're hesitant to try something that isn't laid out step by step. I find that in a lot of classes where the kids really struggle if it's not laid out really clearly. Oh, they're afraid, that failing. Yeah. I also wondered too if that idea of having that willingness to fail is a big one too. I'm adding some notes to the bottom of my presentation so I can remember this later. Curiosity and exploration are missing, and this is tech college students, and they want these step-by-step instructions. Yeah, that's great. Yeah, I would agree with all of these things. So we had my husband and I have been coaching FIRST programs for about 12 years. We've been coaching FIRST programs. So we started with my oldest son, and he was in 4th grade when we started coaching FIRST Lego League. Now it's FIRST something, I don't know. Anyway, and then we coach FIRST Tech Challenge. The kids, okay, we built the missions. We got all the missions built. Then we're working on the robot, and we're trying to build attachments. And we have kids standing at the table with their hands behind their backs. So we're trying to get them to think about how they're going to build an attachment. So I sit on the floor with a group of a few girls, and I say, okay, how can we build this attachment? We need something to go straight out, and then we need something to go up from that. How can we build that angle? And the girls, instead of grabbing from the pile of Legos that's in the middle of our circle, their hands are still like on their laps. They're not going to touch them. They're not going to touch them. They're like, I need you to think about how can we change that angle from, we're just making a right angle with some Lego Technic parts. It was so hard. And we found that through the entire season, we had kids who their instinct when they were in front of the robot was to have the hands behind their back tucked away. I even have a picture of it because I thought it was so interesting that it happened week after week. Getting them to actually touch it was the hard part. And this is 4th grade. They already were hesitant to fail. They were hesitant to do something without a drawing in front of them that says, spell it out. This is how you do it. That seems so young to me. So when we're, as a Spanish teacher, one of the things that we talked about was kids don't start learning Spanish usually till they're a bit older. And there's something that comes in the way of them being able to acquire that language. And they called it affective filter. This affective filter is something that goes up that says, I am anxious about this. I can't let myself relax and fail and say things that probably are going to sound funny. And so I would find that with my Spanish students, that hesitancy to just go for it, to just spit out the language, try to roll your R's, try to pronounce whatever it is. The same thing happens in STEM because a lot of kids aren't having it till later. So that affective filter, that hesitancy to go for it is gone. So now we have to, I found that as a Spanish teacher, you have to do cartwheels, right? You have to sing La Cucaracha loudly and demonstrate that willingness to like just go for it, almost a little over the top to get your kids to say, in this class, we're safe. We can do things that are fun and we can try and we can kind of be messy about it because it does require some messiness. So I thank you guys for your ideas on that. I'm going to also, well, this will be in the recorded, so I don't need to take a screenshot of your ideas because I will have them later. But I'm going to add those in. So now we're going to talk about what does a good STEM activity look like? So what are the qualities of a good STEM activity? And this is going to be, since we have like since we actually have a small group, I thought we might break off into groups, but instead, since there is less than 10 of us, I would like you to answer these questions. A STEM activity that worked really well in my classroom it worked well because. A STEM activity that did not go well was this, and it didn't go well because. And if you're willing to come off mute, I would love that. And if you're not, I would be very happy to read your notes in the comments. So I would love to hear from you. What did you guys feel like worked well and what didn't work well? And you can just come off mute and go. I will, you don't need to raise your hand. I like this comment too, that probably because they're conditioned to be hands off so early, wait and watch the teacher. You know, that is a big, we do it as parents. I mean, you kind of are like, oh, you know, you're gonna make more of a mess of it.
I think we have a machine design competition that we do, and we have. I think it appeals to not only the artists or the painters or the engineers, but it feels like it's inclusive to kids that like their hands on in just about every aspect. And I think that's why it works well. It's not specifically driven towards that programming or the mechanical. Everybody seems to have a place to be able to participate, if I can say, based on what they like to do. So it's almost that all-inclusive experience, if I can say that, where even kids that like to do speaking, maybe lead the team or whatever, there's kind of a place for each and every one of the kids that like to do something. So I think that's why it seems to work well. And the reality is that from an industry perspective, the more diversity I can in my team, the better we're going to have for solutions within our organization. And so that inclusiveness and empowerment of everybody to have a voice sure provides a lot more productive results. So
Yeah. The thing I like about that too, Jason, is that a lot of the stuff that's out there that is hands-on has some, I would say, different inroads to appreciating it or using it. So that is one thing that's nice. Even the difference between that and maybe doing a really more coding activity where you're really just only on the computer. You know, you can find that when you're doing some of these hands-on activities, somebody being able to grab things out of the box and kind of lay them out or mess with this while this over here is happening, it almost gives them this inroad that isn't available in some other activities or disciplines. So I like that. That's great. I think that's an interesting comment that the spatial reasoning is a struggle with one of your students who happens to really like the hand-eye coordination part. That's good. It's an interesting thought too, Tia. Great. I don't know. Okay. I'm gonna give people just a second to continue sharing because I know this takes a little bit to type it out.
I can give a comment or two
by
unmuting, if that's helpful.
Yeah.
An activity that I've led that's been really effective is, we call it solar circuits. And it's where the kids in the classroom put together a little circuit with some solar cells and some wiring, and then they have a little LED, and they can see if they get the LED to light up when a light is shined on their solar cells. And we really go through that activity in lockstep, so everybody has an easy time following along and doing it right. And then there's the opportunity for sort of a little eureka moment at the end when the light turns on. And that has always been really successful. I think what it lacks is, you know, that more independent aspect. So because I think there's more growth opportunity when you're doing something a little more independently. But that being said, it has been pretty effective, and the kids are pretty excited with that eureka moment, and they stay really engaged. On the flip side, an activity that we've done that has been less successful has been a classroom energy audit, where we allow the kids to just kind of like explore the classroom, find all the things that are using electricity, and try to tally up how many kilowatts are required to power their classroom. And it seems like a simple and easy activity to do, but just that more open-ended aspect of it, where we're not going through it step by step by step, everybody doing the exact same thing at the exact same time, has led to more variable outcomes. And it just hasn't been quite as successful.
Yeah, that's great. What do you teach, Zachariah, and what's your grade level?
Well, I'm not a teacher. I do outreach in classrooms for the Minnesota State Energy Center of Excellence. So I'm a frequent guest in classrooms. And the grade level can be anywhere between like 5th grade and 11th grade.
I actually like that whole, I like the word lockstep. So that I wrote it down because I'm like, I'm going to use that, because I think that that is one of the biggest challenges with this stuff is the lack of our ability to do things in lockstep with the kids and then give them the freedom, right? Like if we can do something in lockstep, give a little bit of freedom, give a little more freedom, that's a lot more successful, which is what we do with reading, right? We give them this freedom to read a book, but even that is like more, okay, everybody's reading a book, but we're teaching phonics more in lockstep or whatever it is. That's great. I love the energy audit idea too. That's pretty cool.
Yeah, we were excited about it. The kids were a little bit, maybe it was just that day. They weren't as on point as I had hoped they might be.
Yeah.
We'll keep trying.
That's great. Thank you for sharing with your voice. That's great. Okay, so I'm gonna share from Katie Bussey. So she said that in real life, a STEM activity that worked well for my students was putting a computer back together. The first half of the activity, taking apart, was much harder for them, and they were so afraid of breaking things. That's neat that they worked to put it back together. They actually maybe felt more like, oh, I'm helping, I'm putting it back together, I'm not going to break it when they were taking it apart. And then Mary Lieben said, an activity I've used that's really effective is singing a song about recursion, which is a difficult concept in programming. So that will be fun to listen to. And then Rachel Daly said, kind of a spin-off, as I don't have a direct answer. I teach early childhood at a 2-year community college. And she said, I was thinking recently that was related to STEM was having college students build a bridge with materials they have at home, then connecting to the engineering design in parallel with scientific process using measurement, science, math, prediction, test evaluation, cause, effect, and communication. It's great. And then Tia's question, wondering how you balance the freedom of messy exploration with having some sort of organization. Yes. And we're going to talk about that especially in the part where we are at the end, where we say, how does something messy, how do we reflect on it and have our students, how do we tie that back to what we're trying to teach, especially if it didn't feel like it went well for us, that is key. Okay, this is excellent. I think some other people are going to type. One of the things I was going to say that has worked. So one of the things I would say is that I teach a lot of Turing, tumble, spintronics, and bridge or bust in the classroom. But one of the things that I also teach in the classroom is CAD design, and I teach teachers CAD design, and then we do 3D printing with it. The first time we did CAD design, we made a pencil cup. And so we had to make a cylinder in Tinkercad, and then we had to do a cylindric hole in the middle, and then we were decorating it, and we had to the cylinder was a total bust. So then we changed everybody to doing a cube-shaped pencil cup, because trying to decorate the outside of the cup with like a rounded thing was a disaster. Kids were very uncomfortable using a mouse. They don't use mice. They mostly just use their finger on their trackpad. It was a mess. But the teacher I was working with is my place where I go to try things out. So he was very flexible. and we figured it out together. So then the next time I taught in a class, we made keychains. So with the keychains, all we needed was a rectangular prism, and then we needed to do a cylinder hole in it for the keychain to go in, and then we decorated it. It was flat. It just laid on the plate. It worked well on our printers. Everything worked great. But I think with what Zachariah said, what I did with that group that was better was that initially my lockstep plan was too hard. Even though we were trying to do it all together, I didn't realize where my students were at when I started. And so what might have been good for me is to have them do some playtime first and observe where are these students at with something like using a mouse in Tinkercad, and then plan my lesson of, okay, this is what I think that all the students should be able to do. So I'm just reminded of that. It did actually go pretty well at the end, but in the first day, I thought, oh boy, I have tackled too much. This is a disaster. Okay, Jen shared, I try to balance the messy exploration with a specific end goal that they need to reach by the end of the class. It gives a little more direction, but also allows the kids to run with their own ideas. That's great. Good. So just some like common themes for what worked well. Do you guys mind just sharing? I'm going to put the word lockstep on here. Are there other common themes that you would say that you can just populate in the chat of like, what were we hearing that worked well? I think we can do Jen's, the specific goal that they need to reach.
Yeah, I can elaborate on that too a little bit if that's helpful. I was thinking, like, I build a mousetrap car with my 8th graders,
cool.
and they get to bring in whatever they want to build the car. And so one thing I do is they'll have 2 days where, you know, day 1, you have to have your things here, and then you get 2 days to kind of play. And by the start of class day 3, then you have to have something that looks like a car. Doesn't have to move, but like we should see some progress. And then we keep playing, and, you know, 2 days later, now it should roll. Okay, now, you know, so that they can kind of do whatever they want to make that happen. But like, here's your deadline for when it needs to show a little bit of progress.
What grade level are your students, Jen?
Those are 8th graders.
8th graders.
Mm-hmm.
Yeah, so this, I mean, what you're saying too is like benchmarks, right?
Yeah.
Where we're trying to like say this is our initial benchmark, and they're reasonable benchmarks, right? Not lofty benchmarks like the cylindric cup holder with cylindric decoration on it with a hole that doesn't go all the way through the bottom. Okay, I like this too. Opportunity for Eureka moment, guided but loose structure. Yeah. I know that hands-on stuff, the guided but loose is just this kind of trying to reach it is difficult. I feel like STEM educators I would like to do some kind of like a test of educators, because I feel like STEM educators probably have some of the best classroom management. Because it's hard, right? And then this loose but easy to modify plan, yeah, where you can kind of go with what you're, where you can
Alyssa,
go ahead.
No, I was going to share one of the things that I enjoy doing is adding scaffolded experiences. So, for example, if they're going to create a Rube Goldberg chain reaction machine, start with a hands-on challenge that is figuring out simple machines, and then figuring out how do you connect a sequence of simple machines together, and then just keep building up until you get to that larger goal, but one little exploration step at a time to help build their confidence through that process.
Yeah, that's great. That's great. These are great. And then I do have the, what themes didn't work well. And I feel like we kind of, I think we kind of have that figured out pretty well. So I'm not going to populate that. But, I'm going back to the question, what does a good STEM activity, toy, video, game look like? And this is what I really think, that if students are using their hands and their heads, okay, we got both things happening, that's an excellent activity. They're not experiencing instant success. That is also an important part I mean, if we are scaffolding it so that they can have these little successes, yes, but you know, having that struggle is good. I think also if it's a good activity, we're noticing that not all the solutions are the same. I think with the guided making the solar thing, that would be a situation where we want it all to work the same. But then, you know, in some activities, we want to see that you can achieve the end goal without having all the solutions be the same. And that I'm going to tie a little bit into what our products do. So one of Paul's goals when he was developing Turing Tumble was that there would be an the answer at the bottom with with how the marbles were patterned would tell a student if they achieved the goal. There are solutions in the back of the book, but you can achieve a lot of the puzzles without getting those specific solutions. And so, you know, just like in a computer program, if we're having somebody trying to program a fridge so that it, you know, the ice machine works when you press against the like little ice, you know, lever thing, different engineers are going to engineer that differently, both in how they do the mechanism as well as how they program it. So having not all solutions be the same is a good thing. And then that idea of a productive struggle. So I'm struggling, but at the end, I have this productivity. One of my favorite things when I'm working with spintronics with the students is we look at the resistance. So we have resistors, and the resistors have different resistances. And we talk about, this is not exactly a good one-for-one, but we talk about the resistance in our brains. And so the first day that we do spintronics, I ask them about how is the resistance in your brain? Would you compare it to the 100 resistor, the 200 resistor, or the 500? And oftentimes in that first class, we got a lot of kids who were feeling like their brain was at a 500. It is having trouble getting through accomplishing these goals that we have set out. And by the second time, the second introduction, when we're doing another class period with it, a lot of those kids, their resistance is definitely decreased and they're feeling that like improvement. And I mean, it's the same with strength training. You know, if we always use 10-pound weights, we're not going to get stronger. But if we can up the weights, that's going to help us get stronger. And that's a productive struggle. That's the physical productive struggle. This is one of my favorite ideas is this engineering. Engineering is learned the moment when the materials refuse to cooperate, and helping students understand that when the things aren't cooperating and when we're having to overcome that, that is the challenge. If you've ever used a 3D printer, I taught the fourth graders that were using the 3D printers. I taught them that that if they ran into any of the following problems, they were having the full 3D printer experience. So if the filament got jammed, if the thing didn't stick to the build plate, if they were having a clogged nozzle, if they had this, I went through the whole list and I said, you guys get the full experience. And if we don't have all those experiences while you're printing your classmates' keychains, you didn't learn how to use a 3D printer, because half of a 3D printer is learning how to, you know, troubleshoot it. Okay, so right now I have a little, I have a break built in. So I would like to give the chance to have a break. And then when we come back, the goal is going to be to do some STEM activity examples and brainstorming. And so I have a bunch of, as you can see behind me, I have a bunch of STEM activities. And then I also have some activities that don't require any like things that I have stuff that's low cost, no cost, and medium to high cost. So do you guys feel like we need a 10-minute break, or should we do? Melissa, what do you think? Or Jason, what do you think?
Katie says 10 is great.
Okay. And I think what I'll do for this 10-minute break is I will stay on, and if anybody has any questions or anything, I'll maybe go off for 2 minutes. But then I'll be back on. So if anybody has anything that they want to ask or talk about, you can ask me it or talk about it. Does that sound good? So I'll be off for like 2 or 3 minutes and then I'll be right back on, okay? So we'll be back at 11 a.m.
Hey, Alyssa, I got a really good one for you.
Yeah.
So a couple of these events ago, we had a professor who did research on connecting literacy to engineering,
Mm,
and her name was Meredith Portmouth or something like that.
okay.
And um, and it was she did it through an NSF grant.
Mm,
And what it was you take a children's book and you read a children's book to the group. And then at the end of the children's book, you discuss the characters and you basically do an empathy matrix. Okay.
oh,
And then what you do is you pull out all the craft supplies and you say, now design me and engineer me a solution that would help the character in the book. Any of the character,
um,
any of the characters in the book. So what I found, so I did this with a YMCA group. My daughter was at a YMCA. So I had kids ranging from 6 to 13, 14, something like that. And of course the complexity increased with the age.
mhm.
But what was really fun is where the kid thought about entering into the problem solving area for the character. In other words, the one that we read was Muncha Muncha Muncha. It was about a farmer, issue with the rabbits, getting to his garden, whatever, whatever, whatever. And so, some of the kids were thinking about, well, maybe he should have created an alternative garden, right? So preventative design. Maybe he should have put in vegetables that rabbits don't like. Maybe he needed to go ahead and put in fencing that was more robust. But what was fun was really having the kids then share their engineered designs with the whole group and the vision that they had. We even had ones where they put one kid put a trampoline inside of the garden, so when the rabbits jumped over, they hit the trampoline and they bounced back out. So
Cute.
so it was really clever and creative, and it was messy and it was fun. And the kids really had a good time with it. So, and it was really simple. I thought in the dynamics across the groups of ages of kids was really fun and easy as well, because you could have a whole group of kids across multiple ages. And again, the complexity just increased in their design, but always trying to find the way to help maybe the characters. And they could think of the rabbits as the characters, or they could have thought as a farmer as the character, or whoever they want to show empathy towards in designing solutions for that. And every book, of course, has many characters in it. So I thought
Huh.
it was really interesting. It was really fun. It was really easy. It's a
Uh-huh.
great classroom kind of thing.
Uh-huh.
Um, so, and
I know the nice thing too is that then the kids can use the level that they're at in their engineering too. You're not all
right,
trying to have the same outcome and oh
right,
that kid's thing looks way better than mine turned out or
right.
yeah.
And the solution is whatever solution they could come up with. And the level of sophistication is however creative they want to come up with it. Maybe they're not able to make it out of paper, but they come up with the conceptual idea and they say, well, this represents this.
Yeah, yeah.
So but yet some of them are very talented with paper and whatever, and they were able to go ahead and do that. So I think it provided that flexibility of, maybe kids aren't as good with their fingers on designing some, but yet they have the good concepts in their head. Well, then draw it out or show me, and
Mhm,
but yet build something around it or whatever. So
mhm.
I thought it was really interesting. That was a great resource that we used, and she brought some great ideas to it. So.
I love that too because I feel like a lot of people when they're talking about bringing literacy, and I do this too, bringing literacy to STEM education. I always think that you bring in a book that talks about STEM thing,
Right,
or a
right,
person. You always
right.
kind of go that direction instead of thinking, no, like
It
that
can be
solution, providing a solution for the characters is
right,
even more engineering focused than,
right,
yeah.
right. So it was fun. That was a good one. So
Hmm. I bet it went great. That sounds really fun. I want to try that in my in that test classroom I work in.
Yeah, you'd love it.
Yeah.
And again, what we found, you want to get the age appropriate book, of course. Um, but you know, even if the book is a little bit younger for the whole group, it didn't really make a difference. I mean, they all understood, and they still had, even the older kids still had fun working on it, and some of them worked with the younger kids as well, where they come up with ideas together. So it provided a nice dynamic interaction between maybe an older kid and a younger kid too. So you can
Yeah.
induce that kind of conversations. I thought what was really interesting is that empathy matrix, and ensuring that
Yeah.
they're really thinking about who my customer is, or
Yeah.
who could be my customer. So
Yeah. I haven't heard the term empathy matrix. What is that like? Is that
it's
a
just a
series of questions or
yeah,
like a,
it's a four block of how you understand the characters, or understanding what they're each going through. So there's a new one for you, empathy matrix. So you
it's a
can
new code
understand,
word?
right. Well, and then it allows you to understand your characters and what they're experiencing. So and you can have conversations about that. How do you think they felt? Were they
Yeah.
happy or were they sad? That kind of thing. So
Yeah.
provides those emotional conversations as well, I think. So
Yeah, I know. And that social emotional. I feel
right.
like social emotional learning is at its height when you're doing STEM education because the frustration and the
Right, right,
so
right,
you may as well like just let's go right there.
right, right.
That's great. So fun.
All right, I got to hop onto my other meeting.
Oh, okay. Yeah. Have a good day. Good to see
Thank
you.
you.
Thank you, Jason. That was great. Okay. All right. Well, we're going to get started again, everybody. We're back at 11 o'clock. Hope you had a good little break. So right now we're on to STEM activities and products. So what I want to start with is I want to start with some STEM activities that have to do with awareness of the world around us, that do not have to do with any products at all. So and these are particularly appropriate in terms of like the engineering aspect of things. So first of all, this idea of the things around us and how they work. So my family was on a vacation in Chicago, and I have my husband Paul is the one who designs the games, and then I have 3 boys, all of whom are very engineering minded, and so it's just natural to them. And so our house, when they were young, all kinds of building toys. My oldest son would get like a Think Fun puzzle or one of those puzzle games, and he would work through every single challenge. And over Christmas break, it's just how they're wired. And so for me, I have been immersed in this household, even though that's not exactly my natural bent for how my brain works. So we're on this vacation in Chicago, and we're exiting some kind of bagel shop. And so somebody pushes the door open, and all of a sudden that person backs up, looks up to see what the door mechanism was, because it was a unique door mechanism, and they could tell as soon as they pushed the door it was unique. And so then all the Boswells just hit each other, just like slammed into each other. And then every single person's like looking up, trying to figure out what this door mechanism is, and everybody's making comments on it, and it proceeded down the street. And I tell this story because of this. As a teacher, even if this is not our natural bent, one of the things we can do in our classrooms is to start to draw attention to the things around us and how they work, and making just observations and drawing our kids' attention to things. Because if kids understand how they work, think about it. When they own their own house, when they buy a furniture set and one of the legs is loose, they are, instead of instantly saying, oh, that's broken, it's going to be broken for the next 20 years that I have this item, I want our kids to flip it over, look underneath it. I worked with somebody who was trying to teach STEM education, and I said, when your toilet is running and it just continually runs, do you take the back off of it and look inside? And she was like, I never do that. I was like, you may not be able to fix what's inside, but I want you to start thinking about how can I embody this by actually checking and seeing, I noticed this problem, I'm going to look. So with our classes, I think that is one really simple way to bring STEM education into our class. And this is a more formal activity. I like doing this with students where everybody in the class chooses something simple that they use in daily life to make things easier. So something that makes their daily life easier is technology. So even a pencil, right, is technology. But I would like this thing that they choose to have some kind of mechanism to it. So maybe it's at home, their dishwasher soap dispenser. Maybe it's a pencil sharpener in your classroom. Maybe it's a special door hinge. Maybe it's a pen that has a cap that snaps on, or a pen that you can unscrew and take apart. I want the students to make a prediction. How do you think this works? How do you think this pen comes out the end when I push it in? Well, I'm going to imagine maybe there's a spring in there. Then I'm going to explore it. I'm going to maybe take it apart. I'm going to turn it over. And these are things that don't need to be things that require screwdrivers or any of that. Have them look at it, figure it out, explore it, test the prediction that they made about how it works, and then research online. You know, how does this work? Because I didn't understand why when I pushed the top of the pen down, why that, I'm not seeing in this pen, you can't see it, but I'm not seeing any kind of a spring. And I assumed there was a spring in there. Well, let me see what other kind of mechanisms might work in a pen that when you push it down, it has a nice satisfying click. And then describing your findings. You can also do this with what things are made of. Choose something in your classroom that looks like it's made of multiple types of materials. What materials might it be made of? Is it plastic? Is it metal? Is there wood? What is in it? Explore that item and see, did I miss anything? Did I miss any components of that item? Again, research online, find gaps in your exploration, and describe what you found. Another thing is the things around us and how they are made. So has anybody seen the show How It's Made? It's a kind of dry sometimes, but like really interesting. You can learn about how all kinds of things are made. The most recent one I watched was how blue jeans are made, and it was really cool. I really enjoyed it. And watching an episode, even just part of an episode of how it's made, and then having the students look around the classroom and think, the kids loved learning about injection molding. We watched videos on how injection molding worked. And it was amazing. And they were like all into it. I actually have a little snippet of how Bridger bust is made. So one of the things I do when I'm teaching Bridger bust is at the end of the class, when almost all the boxes are cleaned up, I turn on the how Bridger bust is made video. And after the kids have played with that game, they are all just enamored with this video. It's not even actually, it doesn't even cover everything, but they love the video. So again, with this one, what methods do you think were used to make it? Do you think that it was, saws were used to make it? Do you think that some kind of CNC mill was used to make it? A lot of things are made with injection molding. And then explore it and see if there's other methods you did consider. Things like, what things are screwed together? Is it snapped together? Can I see? I mean, our laptops are good examples. I can't see hardly any screws on my laptop, so I know there's plastic snaps that snap parts of it together. And then describe your findings. So this is a fun way to just no cost, but having the kids both do something and also reflect on it. I really like that. Oh, Mary said that she just watched the one about blue jeans too. And then how important is the prediction piece? So I know prediction, I was not sure that I wanted to use that having a prediction instead of having a completely open perspective. That's a good question. I do think that it's important for them to guess, because maybe more guess is a better word, not prediction, because prediction kind of has this idea that you already have some knowledge. I think it's a good thing for them to guess and then see if they were totally wrong or if they were about right. And then I do think that guessing, if they do this multiple times, I think they'll get better at guessing or predicting how something is made or what it's made of. All right, so now we're going to go through some of the stuff that I have laid out. So when teaching electronics, I just threw together some things. And what I would like is if you have something that you've used, this is the interactive piece. I want you to throw it up on the chat and or come off mute. So with electronics, low or no cost. Donated old electronics and small screwdriver sets. This is one of the best things. Makes a mess, but if there's any way to have kids understand the components of electronics is pretty fun. And one of the teachers did say that they put together the computers, which is also great. Even if it's something small, just taking apart, maybe even a calculator that doesn't work anymore and exploring what is inside of there. What are we seeing? And then higher cost things that I have used with students. So here's a screwdriver set, my little precision screwdriver set. You can get these for really inexpensive on Amazon, and you can actually just pass out a whole bunch of screwdrivers to the students. But other things I've used, snap circuits. Snap circuits is basically like snaps, where you can make your, you can complete your circuit using the little plastic components. And on the plastic components, there are things like wires. Some of them are just straight up wires. Some of them have things like fans. Some of them will split the current. Some of them have switches. And so you could just easily put together a circuit doing that. There's also squishy circuits. Squishy circuits, the whole concept of that is just this idea that the dough can be conductive. Makey is this one over here. Makey is also showing the idea that different kinds of items can be conductive. The guy who invented Makey did a TED Talk where he made a banana piano, and that was what got the attention for Makey. These are very simple kits. When I was working with the STEM educator in one of the schools nearby, she said, what can I do? What should I do first to get the kids sort of activated before they do spintronics? And I knew that they had Makey in the district. So I said, why don't you get the Makeys and have the kids just follow a tutorial on how to make a simple circuit. And the kids loved it. And it was really step by step. And then once we went to spintronics, it was fun to see how that activation of using a different thing that was actual electricity helped them be prepared for spintronics. And then we also have microbit, which microbits, that actually blends in the coding and the electronics, but the little bits are, you put them together. This is the highest cost. Microbit is the highest cost item on this list of things that you can do with electronics. If anybody has anything on electronics, I feel like Zachariah probably has 8 million more things, right?
$8 million might be a little bit of an exaggeration.
Okay, maybe at least 8 more.
We do have some little solar kits that come in a box. Actually, let me grab one and I can show you.
Is there anything else that you feel like that works really well too, if there's anything else? And are the solar kits made by your Center of Excellence, or is it one that anybody can get?
I don't know why I muted myself for those 15 seconds, but now I'm unmuted again. It's sort of a combination of this. You can see the little solar cells here. We use those. It's a combination of this and some other stuff that is cobbled together by one of our staff members. And actually, I asked her the same question, and she just sent me an answer today. So I can forward that to you.
Is it a learning resources kit? It looks kind of learning resources-ish, no?
I don't know. It's called the Solar Deluxe Educational Kit.
Oh, okay.
Not seeing anything. It is made in China. I can tell you that.
Okay, cool. Thank you. That's great. Yeah, and that is neat too for teaching that the energy. One thing that I didn't know when I started teaching how electronics work is just that it is very much in our recent history that we have the electronics that we have ready to go in our homes where we can just plug in an outlet. And a lot of our students have had experience being in places without electricity. So maybe they've gone camping and they've been in a cabin that doesn't have electricity, but it has running water. Those give some really interesting conversations, and it's fun to do electricity before Christmas. And this is why, because you can do a lot with Christmas lights and the idea of like Christmas lights going out in the parallel versus series circuits. And then it's fun when they go and they spend time with their grandparents and they say, hey, do you remember a time when you did not have electricity? I know my grandma and grandpa, they had a farm, and my grandma used a Ringer washing machine all the way until they sold the farm. They didn't even have a washing machine there. The farm did have electricity, but it was rudimentary. And so I know that my dad grew up not having electricity for part of his growing up life. And so that's kind of, it's fun. So I recommend electricity before Christmas. That's just my.
Yes, Christmas lights. That is such a genius idea.
Yeah.
I cannot wait. That's yet another reason to look forward to the Christmas season.
Yeah. And you should, you know, my middle son is a very good helper, and he was helping me put Christmas lights outside. And this year he goes, Mom, I cannot do this. He was so frustrated because we were trying to get lights back in that were burned out. And he was like, can we please just get new ones? And he was so sweet about it. So I was like, all right, we can get better lights. But I should have hung on to the strings. By the point at which you have tried to diagnose the chunk of lights that's out, you are done with it. You want it to go directly in the trash, but I needed to save it for classroom use, and I did not. So that's my recommendation. Don't be so frustrated you throw it away.
I'm with your son. Replacing the little fuses, trying to find I want to do the right thing, but it's not easy.
Save the environment, but not my sanity. Oh, okay. So next thing is computational thinking and coding. I've probably done the most in this realm, but I would love other people's ideas. Lower no cost things for teaching computational thinking and coding. Scratch code.org, hour of code. Okay, we're on the computer for all of these. One thing I love to do that's low cost is having one student as a robot and the other students are coding them to tell them where to go. That's a wonderful way to be an activity before you do Scratch and things like that. There was also this great little Lightbot game that used to be on the computer, but they actually discontinued it, and they have one that's like a rabbit and a bunny one that you can find, but you're telling a robot to go certain paces forward and turn, and those are great. I love the little robots that they have on the market. So we've got Botley, the coding robot. We have Ozobot. Ozobot follows lines, and when it hits a different color, it will do different things. It will spin, it will blink. We have Turing Tumble. Turing Tumble is like a mechanical computer. That's the one that we make. I'll share that later. Robot Turtles. Robot Turtles is more of a board game. And this one can be frustrating because the person running the game is supposed to move the turtles. And it's really easy to get it messed up because you're the one laying out the cards to say, these are the steps I'm going to take. And so when you're the one laying out the cards and then you're moving your item in a direction, it's really easy to make a mistake and not realize you made a mistake. So it's not really the best one always. And then we've got Sphero. If anybody's used Sphero, Spheros are great. I have the Sphero Bolt right here. I have multiple of these. And the Sphero Indie is glorious. So this one's my favorite one. It has this one is meant for younger kids, but I think it works great even with the older kids. It's a little car, and you actually put these mats down that are different colors, and then the Sphero Indie does different things, but it hits the color of the mat. And I do think that it doesn't look super juvenile, so it can be used with older grades, even though their intention was for the younger grades. And then you also have the Dash Robot. And the Dash Robot was really popular for a while. I don't know where he went. Anyway, we have a Dash Robot somewhere, but that one, I'll show you on the picture right here. The Dash Robot looks like this. And a lot of these. So the Dash Robot requires that you have an iPad to go with it, as does the Sphero. So I showed the Sphero Spark right here. You have to have an iPad or a Chromebook that runs it. So the frustration level can be high if your technology is laggy. The Indie does not require having a block-coded tablet or something to go with it. Nor does Botley, and nor does Ozobot. So that's a nice thing. And then for unplugged games, we have Robot Turtles and Turing Tumble. So I'm going to see if anybody, Little Bits, yes. And I forgot Little Bits. I got to add that. Thank you. I did micro bits, and so then I forgot about Little Bits. And then Goldie Blocks. I do like Goldie Blocks for early engineering. I think some of their things are better than other ones. I like that they come with a book. In fact, that's why we did a story with Turing Tumble that is a graphic novel, because Goldilocks had done that. And we thought it was really neat how you could engage different kids because of the story aspect, and then they get kind of sucked into engineering if they're maybe more interested in the story to start. So CAD for computer aided design stuff. Lower no cost would be Tinkercad and GIMP. GIMP is one that you can do. It's kind of like flat, so GIMP works with like a laser cutter. Oh, this is great. The Finch robot is recommended by Mary. So I'm going to write that down. I'm going to take a look at that too. And Mary, does the Finch robot require like a tablet or something on the side, or can you manage it right from the robot?
Yeah, it does require a tablet, but it's specifically for teaching programming. So you can teach like a block style programming, or you can teach Python or Java, depending on the age of your students and their abilities. So it goes all the way from, I don't know, probably elementary school through college.
Great. I love too that you can actually graduate from the block programming, because that is important for some of our students that are really ahead in their programming to not be stuck with just the block. That's great. I'm going to look into that. And Raspberry Pis. Yeah, we have a Raspberry Pi too. Is Raspberry Pi though reusable?
I'm sorry, is it what?
Like with Raspberry Pi, the one we had, you put it together and then it's like, it is what it is. Do you have your students putting them together?
Yeah.
Oh, no, not Raspberry Pi. I'm thinking of a different thing, the orange one.
Oh, yeah, Raspberry Pis. It depends on the type of kit you buy. You can buy one where the students have to build the computer, or you can buy a Raspberry Pi that's already all set up and is its own computer. And you can buy kits that have like little lights and motors and sensors and stuff that you can connect to the Raspberry Pi and then operate those.
Yeah, that's great, because Raspberry, I was thinking of the Piper computer, and then oh, and the Edison robots. I know people love those. All right, I will add to my list. Great. Okay, so going on to the CAD. So of course, getting things to actually print out once you've done them in CAD is the trick. So the 3Doodler pen or the Scribe 3D printing pen, those are great for the idea of what does a 3D printer do, where it's laying on layers of something and they need to be attached to something else in order to go up in, height. But then ideally we would have 3D printers. And I have had the least success with Ultimakers and Enders in the classroom. I have had the most success with Prusas, and Bamboo Labs are amazing. There's very little troubleshooting you need to do. But of course, that's expensive. And then you need the filament. And then there's also vinyl cutters, like a Cricut, or there's all kinds of vinyl cutters. And then oftentimes those have their own software that goes with them. But those are very fun for letting the kids actually make things that are that look really more professional. It gives them that, it goes from this kind of stuff takes them from having their engineering look more like craft projects to having it look more professional or something they'd want to maybe even give somebody. So this is the 3Doodler. And the guy who makes the 3Doodler, he during COVID built out his curriculum quite well, so that you can even get like bags of laminated cards that show kids how to make certain structures. And he did a really nice job on it, and it did really well. Like in the New York public schools, he sold a ton of kits during COVID because the teachers could send them home. They could be easily sanitized. It was great. And I haven't used the Scribe 3D pen, but that gets really good reviews. And then I have a Cricut here just to show a vinyl cutter, and then there's the Bamboo. I think that's an A1. A1, yeah. And then physics and building supplies. So lower, no cost. Of course, are like recycling and craft. And I think with this group, I probably have you guys probably have lots more to add to this. Maybe again, 8 million ideas. Higher cost things would be for physics would be this new Sphero blueprints. that works great. It's built to the standards, so it shows inclined planes and all kinds of that fit all those physics concepts. And it does it specifically to teach those physics standards that the students are hitting. And then Bridge or Bust. You learn a ton from Bridge or Bust. That's our game about the physics of bridge building. If anybody has anything to add to this, let me know. Oh yeah, this is what the Sphero, sorry. This is what the Sphero Blueprints kit looks like. And then we have Bridge or Bust in here. And then robotics. So robotics, I think, is always I think robotics is hard to teach. I have a friend who's a 4th grade teacher in a school nearby, and they have a full cart of Lego Mindstorms, and she's tried to implement them in her classroom and just feels frustrated. I think that the Weebots do a pretty good job of making it a little more, bringing it a little more into simplicity. Even Vex Robotics, possibly those parts are a little easier to manage, better than Mindstorms. And then the Spike Prime, you're using it with the Lego Technic pieces, which can kind of feel difficult. And I've never used MakeBlock, but if anybody has stuff to add to this on robotics, there's some really good online simulators too. But again, those have their limitations. One of my favorite things that was put out was Amazon, and this was coding based, but Amazon put out one where you were trying to deliver packages or you're trying to pick and pack. So you were sending the robots to certain locations to get certain items to bring to the pick and pack location. And I really loved that because it was definitely like a real world thing the kids could imagine. There's a warehouse that's trying to get me my flour from this aisle and then come back. So it was good. Yeah, I have a lot of children's picture books that I did not grab. I have a whole row of them. I can get those to people after the class is done because I have a lot of children's picture books. My newest in my library of children's picture books is books about bridges. And there are a ton of those. It's really fun to learn about how different bridges were built. And then here's some of my STEM free play or guided play things that I love to use. So we have magnetiles, blocks. Kiva blocks are especially good because they have dimensional accuracy that allows you to do some different things. Like if you turn it on its side, it's the same as 3 of them flat. Another company that has been doing a ton of stuff is Lakeshore Learning. And Lakeshore Learning even now has out a little robot that's kind of like the Ozobot, but they have, I'm going to grab these. Oh yeah, here are my little bits. I did actually think of little bits. I just didn't add them to my list. But these are great for primary. And I think if you can kind of hide the primary part of them, some of them are great. Like this one is 3 Billy Goats Gruffed bridge building activity, and it has little cards in it on how to build different plans. These are super fun. And then they have this one that's a Goldilocks one where you're trying to make chairs for the Goldilocks characters that are strong enough to hold the Papa Bear, Mama Bear, and Baby Bear. This one's very fun. And then they also have this Code and Go mouse that I was not expecting to like. But this one is awesome. You actually build a track for the mouse to go through, and then you send the mouse through. I really wish Lakeshore would. I know their main audience is these pre-primary, but some of the stuff that they do is so accessible. I wish that it didn't have such a kiddie sort of package to it because they really do a good job. Think Fun games and Smart games. They're like the Tray Logic puzzle toys. Those are fun to just have in your classroom as a thing to do on a rainy day, or when they're in indoor recess. And then Trestle Tracks and Gravitrax. Those are just building ones where you're sending something down a track. The Marvelous Marble Run or other marble runs. And then of course, Lego is always nice to have, especially in older grades, to have Lego Technic stuff is really helpful. But this stuff, I think, if we go back to the idea of what makes for a good STEM toy or a STEM product, these are the things that I will put out there as my things. They're using their hands and their heads. They're not experiencing instant success. They're noticing that the solutions are not all the same, and they're experiencing this whole productive struggle. I really feel like if you can run your, if you have a budget and you're like, I want to buy something that does this, and you can run it through these checks and say, yes, I think it would at least hit 3 out of the 4 of these, I would say that's a good STEM education item to have in my class. Yeah, and thank you, Cecilia, for that about building that STEM familiarity without going over their heads. I think if you're a pre-K teacher, looking at the Lakeshore stuff is key. I really like what they're putting out, and I noticed when I was putting together this presentation, there was even more stuff that I don't even have in my STEM library. Okay, so now we have about an hour left. I'm going to move our break down just a little bit so that it hits, hold on. No, I have 3 10-minute breaks. So this would actually be a good time because we've been at it for a half an hour. Let me do turn tumble and then let's do a 10-minute break. Okay. I want to take a moment if anybody has any questions or things that they'd like me to flesh out, or anything that anybody has, just put it up there while I'm taking out turn tumble. Okay. All right. I feel like I need to have like some kind of a cage system for all my stuff today, so I don't knock it over. All right, let's go. Let's dive into turn tumble. We're going to do turn tumble. That'll take about a little under 10 minutes, and then we're going to take a 10-minute break again. Okay. I'm going to actually. So I think the thing, because we're in a shorter amount of time, like we're not just doing turn tumble for a big session. I think it will be helpful for you to see the videos of our games so that you can kind of see them in action. If you guys could just raise your hands if you are familiar with, how about if you raise your hand if you're familiar with turn tumble? Oh, we got like 3. Okay, we got more than 3. Did the hands stay up? Okay. And if you're familiar with turn tumble, are you really familiar with it? Or like, okay, great. Okay, so I think what I'm going to do is I'm going to show you the video because I think it'll be helpful for everybody to see the video of how it works. It's a very quick way to like just have an intro to it. And then I'm going to show you a few other things. So I'm going to include the sound so that the video actually works. All right, so this is turn tumble. Okay, so that gives you just a quick overview of what turn tumble is. Hold on. We're gonna see it again, I guess. No, I'm gonna try to. I just gotta move this. Oh, here we go. I couldn't find my presentation. Okay, so when we're teaching turn tumble, what we're teaching is we're teaching how computers work. Now, this is confusing because when we say computers to kids, like how computers work, what they associate that with is the screen and the keyboard and the mouse and the game that shows up on the screen. That's what they initially think of it as. So one of the things that we have to do is we have to draw them back to understand that a computer is actually not the package that you're seeing. The computer is the thing that is computing. It's the thing that's taking in information, processing it, and spitting something back out. So we look at these computer parts and we say, of all these parts, which parts that you're looking at are processing information? They're actually like making a decision versus what things are input, what things are output, what things are storage. And the kids are pretty good at identifying that, like, you know, a speaker would be output, or a camera would be input, or a microphone would be input. And then of course we have things that are a little more confusing, like this scanner copier is input and output, and there is a processor inside of it. But what we're looking at just at a face value is this right here, this Intel Core i5 is what is processing the information. And then we put it into these categories. So we have the processing is just one thing. We have our input, our output, and our storage, or all these other aspects. And that the computing part of a computer is this extremely small hidden part of what is inside of it. And so we have this enormous Turing tumble that's got a big board, and we are showing them this is a computer, and it's more comparable to the size of their Chromebook, but saying that this big enormous thing is trying to teach us what's happening at a microscopic level, actually even smaller than microscopic, is hard for them to understand. It's a big analogy, a big mental leap for them. So I do like to take this into classrooms. I have an old desktop computer, and I remove the fan, and then I show them that this right here is the CPU. And everything, well, actually it's this thing right here. I moved it off of its holding spot. So this right here is the CPU, and everything around it is all there to support the processing that's happening inside the computer. And then we have this big fan that's keeping it cool, because a lot of our computers nowadays are solid state, and they don't need to have, they don't need to be cool because they're solid state. So I'm going to show you this. So one of the things that we do with Turing Tumble is we have, hold on, tumble together. We have this simulator. And I've had some teachers that what they'll do is, if they're working with kids in their classroom on Turing Tumble, they'll maybe even they'll have the kids work on the boards, which is much preferable to the simulator. But then when they're working as a class, they can put these parts on the board to be able to see more easily as a group, and to even solve challenges. So for example, with Turing Tumble, I'm going to show you the first. Oh, funny. Okay, it's not there. I was going to show you the first puzzle. It looks like this. So the first puzzle looks like this. So what the kids are given is they're given a page that shows this starting setup. So this is the starting setup for the first puzzle. And then they're told on the same page in visual that they can add 5 more ramps to the board in order to solve the puzzle. The end result of the puzzle is that they would have blue marbles at the bottom, and only blue marbles. And they can trigger the left button or the right button to get that. So then the students would put the extra parts on the board to do this. I'll show you a more fun example after this. I just want to show you kind of how it works. So they'll put their parts on the board, then they'll hit the left trigger, and they'll send the marbles down. And they have achieved the objective if only blue marbles reach the bottom. Now, as you work through the puzzles, it'll have you do different things. It'll have you generate a pattern like blue-red marbles, or blue-blue-red, or 3 blue and a red. And then as you go even further, it's going to have you do much more complicated things. Like you're going to have to count, or you're going to have this pattern that's really unique, or you're going to have to capture a certain marble. In this simulator, there's also here, you can get the challenges. So like the first challenge is gravity, and it gives you the instructions here so that you can see what it is. And then you can solve the problem. And it goes all the way to like this one, where you're supposed to do challenge number 29, where you're supposed to do a 1-shot switch. Now, excuse me. Now with Turing Tumble, it's kind of hard to see when you're initially doing it. It's hard to see how it's a computer. So your kids, your students, if they're playing with the game, they are not making that leap to how it's a computer right off the bat. That is something that they will get to once they get to maybe 3 sessions of playing with it. However, in the meantime, the students are learning all kinds of things because right on the board, because this is a physical puzzle that they're working with, they're learning things like problem solving. They are learning how to change their design in order to get the right answer. They are learning logic. They're trying to figure out, if I put these parts on the board, what's going to happen. So one thing that people really enjoy seeing is that is that whole like, okay, let's just look and see, how is this a computer? So I'm going to do a demonstration for you that's just for fun. So this demonstration is going to show how Turing Tumble can count. And you probably aren't going to understand this the first time you see it, but if you see it again in the future, you will understand this. I work with a bunch of teachers in Washington State, and I was out there for an in-person session, and I've worked with them a lot of times. And I showed them this demonstration, and I had a couple people, after I did it once, I was like, do you want me to show it to you again? And they were like, yeah. And I had a couple teachers come, and they sat down on this dirty tile floor, and they were like, do it again. And then after I did it that time, a bunch more teachers came up and sat on the tile floor, and they're like, do it again. I ended up doing the demonstration 5 times, and some of the teachers were recording it, and they were like, you could see that their heads were starting to get the idea. So the blue parts on the board are the switches, and the switches are what make Turing Tumble a computer. Because when you are moving the switches left or right, you are programming it. So I'm going to show you how it can count, and that's all I'm going to show you today. And if you want more information about Turing Tumble, I'm happy to give it to you. But this is going to count to 8 and stop, and it's counting in binary. So raise your hand if you've ever done binary. Has anyone done binary? Kim's done binary. Katie's done binary. Rob? Great. I actually have 3 people doing binary. That's great. Good. Okay. So this right here is the 1 spot. This is the 2 spot. This is the 4 spot. And this is the 8th spot. And binary cards as magic tricks are so much fun. Yes, that's great. Awesome. I also do a human computer where everybody is one of the switches, and that's a pretty fun activity too. So here's what we're gonna do. We're gonna trigger it, and when this is pointed to the right, it's on. When it's pointed to the left, it's off. And the kids do get to this pretty soon where they're starting to use these as switches, and they don't really know they're counting in binary till they get a little bit further, but they start to use them and they start to make the connection. So when a ball comes down and turns it to the right, then that's a 1 because that's the 1 spot. Now it's going to come down, it's going to turn that off and that on. This is the 2 spot. So we have 2 marbles. Off, or both of these are on, 1 and 2, so that makes 3. Off, off, on. This is the 4 spot. And then it's going to turn it on. 4 and 1 is 5. This one's going to get turned off. This one's turned on. 4 and 2 is 6. And this is 4 and 2 and 1 is 7. And then off, 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 and 8 is going in the hole. So that might be a little bit like of a stretch, but now you have seen Turing Tumble. So now you know what that is. Okay. I'm going to give you all a little break, and I'm going to stay here because I don't need a break. So if anybody has anything they want to talk about, I'll be here. But we're going to give you a break, and if you guys could come back at 11:50, that would be amazing. And then we'll do our final 2 games, and then we'll do the final. I was going to try to put 11:50 in the chat, but I'm not having success typing in the chat. So come back at 11:50. Welcome back, Jason.
Hey, thank you. This is a little bit more enjoyable than my previous meeting, but I'm back.
What was your previous meeting?
We're presenting to the Board of Trustees. So in preparation to present to the Board of Trustees about what the centers do, we're trying to get our arms around engaging industry, enhancing education, and inspiring students. So K-12 to and career pathways to college and university engagements to industry engagements, and those aspects of all of our centers and how we do that together and support the universities and colleges. So
Okay, wow.
yeah, a lot of
So was it
excitement.
all the centers were all at this meeting?
Yep, all the directors
Oh,
were.
wow. Oh, that's great.
Yep. So there's 7 of us, and we were there visiting about how we plan to make this go. So
That's great. So do you guys all get the same amount of funding from the state, or is it?
each center's allocated a different amount, and
Okay.
so we are each one has, and how that was decided was previous leadership. I don't know. Melissa and I both struggled with the decision-making process and all that stuff, but no, we're not all funded the same. And so then that ends up being a challenge with regards to, you know, funding directly correlates to resources, and your ability to do outreach or connection is and make an impact, right? So if you're not getting as much funding as other centers are getting, there you sit. So
Yeah. And then you can't say the demonstrated impact is worse, but it's
right,
also based on the fact you didn't have as much funding.
right, you're exactly right. So it's an interesting correlation. So we have to be very strategic in what we do and how we do it as a center. So we're a little bit more finding ways to engage educators so we can get a multiplier effect on engaging young people, right?
Yeah.
And then we deal with industry consortiums. We also do a lot of advisory councils that we serve on across the state. So leveraging our expertise in the areas that we're able to support. So kind of more, we're trying to put ourselves more in a position of what do they call that? Thought leadership is what I think is what we try to put ourselves into, more of that positioning. So, and when you only have 2, that's what you have to kind of do, is position what can you do from a leadership standpoint and engaging in organizations that support those leadership opportunities for kids and industry and that kind of thing. So
Yeah.
yeah. So yeah,
And
go ahead. I'm sorry.
are there literally just you and Melissa, or really the whole team for engineering?
Yep.
Wow.
Yep.
Which team has the most people?
You're asking most people or most funding? I think I'm just going to leave it at most people. I think, well, there's been a lot of turnover with a lot of the centers. So my guess is healthcare, I think, has about 5
Oh, yeah.
5 people, something like that. Health Force does, I think. So, yeah, so that's what, but my IT is short-staffed and transportation is short-staffed, and energy's trying to build their way up staffing wise, and it's hard. Workday's been a real struggle to deal with across the Min-State system. That's our new um, operational software, if I might say, that does all your budgeting and financial stuff, and that's been a challenge across the system. So that also involves HR. So yeah, that's been a real pain in the rumpus, but we deal with it. Yeah, so we've decided upon as a center that we leverage AI a lot, which has been very advantageous for us on driving some of the opportunities that we have to help us become more efficient in what we do and innovative in what we do as well. So yeah, so that's a lot in a nutshell. So, but it's fun. I mean, we could have one day where we're in a 3rd grade class, to the next day I do some adjunct for mechanical engineering, senior design, to Melissa has some students that she deals with from that are homeschool students to walking a shop with an industry member, talking about flow and what they're doing for their processes and their manufacturing plant, to going to a community and talking about workforce challenges and what they're doing for workforce challenges. Um, so we're kind of all over the boat. We got kind of get to play in all those areas.
Yeah, wow. Yeah, lots of variety.
Yeah, it's fun. That's good. It's good to have variety.
That's great. I don't know how to add something to the chat. It's nice that we had, I mean, it's nice that in this session we've got all kinds of people coming from all different backgrounds, like early childhood and
Right.
Yeah.
Yeah, that diversity is nice. In different views, different ideas, that kind of thing.
Yeah, yeah.
Alyssa, you don't have
Thanks.
access to the chat?
Yeah, for some reason I can't chat. I was wondering if it's because I am not like logged in or something.
No, I don't think that would be the case. Okay.
Yeah, anyway, it's all right though, because I don't really need the chat. It's fine. I was gonna put in the when I get, because we're getting close, I was gonna put in the thing for people to sign up. But they can just use the QR code, I'm sure, with their phones. It won't be hard. And it's not like it's a long survey.
Okay, if you want to send it to me via quick email real quick, and I can.
Yeah, I'll send it to you via email. That would be great. Yeah, I kept trying to like chat back, and I like was trying to like hit on it, but I wasn't having success. Okay. Okay. Right, we're back at it. All right, Melissa, I just sent you the thing. Okay. Okay, so we're gonna get back to it, everybody. So I'm gonna go through quick what Spintronics is and what Bridger Bust is, so that you understand what our games are like. Again, if we're going back to the idea that a quality STEM education product has these elements, they're using their hands and their heads, they're not experiencing instant success, they notice the solutions are not the same, and they're having the productive struggle, it's a good quality STEM education toy. The thing I like about our products is we were talking earlier about how you want to be able to have this structure, this scaffolding, this kind of ability for a student to grow. And with our games, we always do gradual increase of challenge. So the first puzzle is going to be easier. And then as different parts are unlocked in the puzzle book, you're getting easier challenges again, and then they're amping up again. So your students are starting here and they're working through puzzles, and then maybe a new part is introduced and they get to go back down a little bit, build again, then a new part is introduced, they're going down again a little bit, and each time though, they're not going down quite as far in terms of their understanding of the game itself, but also of the logic or the task we're trying to help them understand and learn. Spintronics also has similar components to Turing Tumble. So with Spintronics, we have a puzzle book. And well, actually, I'm just going to do the video. I should stop sharing and share again with the volume so that you can hear it. I'm going to show the video again so that you can actually see what Spintronics is in a nutshell. Oh, this is actually not the video. This is just showing one of the Spintronic circuits running. And you can see on this, it's a bunch of sprockets, chain going around them, and it's very steampunkish, right? Each one of these Spintronics parts has an electronic counterpart. So when we're working with, I'm going to pause it when it's at the top. Okay. So when we are working with actual electronic components, we have things like resistors, transistors, a junction where we're splitting wires. We have switches, we have ammeters where we know how fast the current's going. We have capacitors. Every single one of the Spintronics parts has an electronic counterpart. And one of the things that was amazing to me in working with Spintronics is that we look at the inside of that computer that I showed earlier, and there's all kinds of parts in there. But even though there's all kinds of parts in there, there are really only about 5 distinct parts that are used in any electronic device that we have. They are all, we have a bunch of them used with different values, but there aren't that many different parts that compose the electronics that we're used to. So I'm going to show you the video of spintronics. Okay, so that's spintronics in a nutshell. One of the things that we have trouble with, I'm glad that you think it looks like fun, Katie, that's good to hear. One of the things that kids struggle with is when they hear the word electronics, they associate it with their iPad. Like the parents will say, you have, 1 hour of electronics time per day. So helping them understand that electronics is actually anything that's powered by current, even things that are battery powered, is a whole thing. And we have a lot of fun in the classroom, kind of deconstructing electronics and what it is. One of the most fun things is to have the kids go home, and one of their assignments is to just stand in their kitchen and count up how many things in their kitchen are electronics. So anything that you would plug in, or you would charge, or you would have any kind of battery in it. And it's just amazing how many electronic devices that they have. When we are doing spintronics, it's fun because you can really see what would be happening inside of wires. So the first kind of myth that that we debunk with spintronics is this idea that when you turn on a light switch and the light immediately goes on, we think of the electricity just zipping through the wire super fast. In fact, the kids will often say, if I say, how fast are the electrons traveling? They will say at the speed of light, right? Because the light is immediately turning on up above in our classroom. And so helping them understand that instead of the electricity going fast through the wire, instead we have electrons all stacked up inside those wires like little balls inside of a tube. And when we open, or when we turn on a switch, we're letting the path open, and one electron or whatever is coming in one end and it's popping out the other end. And so all the electrons are all there ready to go, ready to power that thing that you are turning on or plugging in. And that the electrons going through the wires are traveling at about the same rate as the chains are traveling around the circuits of spintronics. So the same rate that we see in spintronics is really comparable to what's happening with the electricity that is in our walls. The kids also love we talk about voltage and current, and we talk about voltage, current, and resistance, and we do some fun activities where we have me sitting on a little like footstool kind of thing, and one of the kids pushing me, and we try to get a kid who feels like they're really strong and a kid who feels like they're not as strong. We talk about the difference in my resistance versus the resistance of a small classmate. And we have a lot of fun. We talk about like batteries inside remotes and how different batteries put out a different amount of current for the different items that we're using. So this is exactly, Richard, an analogy to a circuit. So what we're trying to do is this was made as a physical representation of electronics. So yes, and this is the thing with spintronics, is that it does have the possibility of creating more misconceptions. And one of the things that we have found with spintronics is that it is the thing that doesn't have the misconceptions like when we use water or things like that, because of the circuits that we're able to build. So you are actually able to build any electronic circuit with spintronics. And we do totally bring it back to electricity at the end. In fact, I really like to use some of these other things to go with it. Like I mentioned before, some of the classes will use makey, or some of them will use the squishy circuits, or some of them will use snap circuits. And we have them building the circuits side by side. So they're building the spintronic circuit, they're building the other circuit, and they're comparing and seeing. Inside our spintronics book, in all of our games, we have a story that goes along with it that's spread out throughout the puzzle book. And so, but with spintronics, we actually put tutorials right into it. So as you are working through it, you are learning electronics concepts. And that doesn't actually, these 2 pages don't show it. I have more pages that show it, but we're teaching, we're even teaching and showing circuit diagramming, and then they're using those circuit diagrams to build the circuits. So one of the places that's kind of fun is, are you guys familiar with the college up in Thief River Falls? What is the name of it? MCTC. It's the one that's like the Center for Autonomous Technologies. So up in Thief River Falls, they have this Center for Autonomous Technologies in Minnesota. It's one of the it's one of the 3 top autonomous technology schools that are in the nation. And so they have an entire hangar that's all drones, and they do some really cool things up there. But what they find is that their students who are taking electronics are often more hands-on kids. And so when they take an electronics class, the math trips them up pretty fast. So they've been using spintronics for the past, I think it's been about 5 years, where in their intro to electronics course, they have their students using spintronics in conjunction with introducing some of the mathy electronics concepts and giving them kind of a foundational idea of this is what's happening in the circuit. And then now we're going to apply the math, and we're going to use the real breadboards, and we're going to use the real resistors and the real wires, and we're going to build these circuits and understand them. So the challenges for spintronics look similar to Turing Tumble. I didn't have that page pulled up for Turing Tumble. Actually, let me pull it up. So like Turing Tumble, I added this page. So we have an objective at the top. We have the required output, what you start your setup with, and the available parts you add to get the output. Spintronics is similar. So in our puzzle book, we have the challenge in words. Sometimes there's diagrams too. The starting setup, what you add with your own creative thought to the puzzle to get the answer up here. And then we always have a difficulty level. So that's spintronics in a nutshell. Now for Bridge or Bust. So Bridge or Bust is our new game. And I'm going to come off my sharing so I can show you the game here because I have it in person. So Bridge or Bust, I have this set up. And this is like maybe the 3rd puzzle. And with Bridge or Bust, how it works is you're given a diagram. Actually, I take it back. I'm going to share again. You're given a diagram like, I'm going to just skip hold on. You're given a diagram like this, where you are shown, these are the parts that you add. So we have these breakable parts right here. And these breakable parts can be broken through compressive force or tensile force, okay? And there is a magnet that holds them together. So when you're building a bridge, if there's too much pressure on it in a certain way, it'll crunch together and your bridge will fall with a satisfying, and it's very cool. But you are not starting over at the beginning. So when we're doing bridge building with our kids and we're using balsa wood or we're using toothpicks and marshmallows or whatever, as soon as the kid's bridge gets broken, you're starting all over. And to try to replicate that bridge using the same methods, even the same gluing process, is nearly impossible. So they don't get to iterate. So our bridge building game is meant so that kids can iterate on it. And I find that because Bridge or Bust is not analogous to real bridges, you're actually building it with, you're just scaling it down. Spintronics and Turing Tumble both are representing something different than what they are. The bridge game is very easy for kids to start making the connections. So I taught the kids tensile and compressive forces, and within 2 minutes, I heard one of the boys saying, hey, over here, there's compression happening. I need you to do whatever. And it was awesome because they immediately applied what I had told them. So these rough adjustment parts get to be added to your bridge to make it longer. So each of these parts kind of needs to be lengthened for the purposes of building the puzzle. So if you look over here at this puzzle that I have drawn up, it'll say you need to add 3 of these breakable parts with the red little arm extenders. I have orange ones on this, but little short red extenders. And then there's a fine adjustment, and the fine adjustment can be done like this. So with your part, if you look at it, when I turn it in, I'm going down to 0, it gets shorter, and then I can make it longer with my crank for my rough adjustment. So the 0 means put on the short arms, adjust it to 0, and you're ready to roll. Now, each puzzle also has little red X's, like the do not go. And these little red things mean you cannot attach a part here. Now, if we were to build this bridge and try to put the boat under it, it's not going to fit because it sags. So as a student, you have to figure out, what am I going to add to push the bridge up so that the boat can fit under it? And with this puzzle, I'm going to attach to this side over here, and they just snap on. And I attach to this side here. And I'm just going to snap that on, and I'm going to adjust it really big, and I'm going to see how it looks. This one I'm going to adjust really big and see how it looks. And I'm going to see, are these parts sufficient in order to make sure that this boat with the small sail can go under? And I'm realizing right now that actually the boat still can't go under. So what I'm going to need to do is I'm going to need to use the green arms to be able to solve that puzzle. Hold on. Okay, so I would have to do the green arms in order to solve this puzzle. But just for the argument's sake, I'm going to start the truck across the bridge. So this truck also on our puzzles usually has in the back of the truck, there's a weight. So there's a wood stack, there's a toolbox, and then there's 3 of these wooden canisters that you can put on, barrels that you can put on the truck. And so for this puzzle, it's supposed to be 1 wood stack, and then we see if the truck can go across. So I wind it up, I send it across, and then it's going to, if it flips up the flag at the end, it's 1. Now this one I didn't actually win because my bridge doesn't, or my little boat doesn't fit under. But one of the puzzles has you able to add the attachments here to here, and then the boat can go under. That's just a different puzzle that's not there. So with this game, I will say this: I worked in 2 classrooms just in the last couple of weeks, and I found that this bridge game can be played a long time. The first teacher where I do my test classroom stuff in, he gave me 2 hours, and I taught them how to play. The kids played, and we could have gone for another hour. It was amazing. All the kids were super on it. And then the next teacher, I was like, can I have more than an hour? Because with an hour, or 45 minutes, I wouldn't have gotten to the point where they could really play. So she was able to give me an hour and a half, and the kids we just kept going. So I have had, this takes a little more setup time than the other 2 games, but I have had a lot of fun trying it out in classrooms and seeing how it works. And then the kids also really enjoyed some of the components of this puzzle book. So this one's a little different than the other 2. There still is a story, but each of the puzzles is laid out like this in a very colorful way. And when you work through the puzzles, you'll find that the weather changes. And as the weather changes, that indicates how difficult the puzzles are. So it's kind of a fun visual difference, and it also draws in kids in a different sort of way. So like when the volcano is going off, that means you are playing the hardest puzzle. And then the story that goes along this one is dogs. They're on an island and they are trying to figure out how to get across to Dog Park Island, trying to cross an archipelago. And every time they try to swim to the other side, they end up back where they started. And so they have to try to build bridges to go across to the archipelago. And we do try to add some variety in here. So our main character here is Rocky. And Rocky has some idiosyncrasies. He's not a dog that he doesn't feel like he's like other dogs. And so that also gets played out in the story. So that's the bridge game right here. And I think that maybe we will just let's just watch the bridge video because this one's a pretty fun one. And then you'll get a sense of what the bridge game is like. Oh, nope, hold on. I'm gonna go back. That's actually the manufacturing video that I do want to show you a little bit of that. Here we go, let's do this.
This is Bridge or Bust, the ultimate bridge building adventure. The new toy where bridges either stand tall or come crashing down. You can design them, test them, and reset in seconds. Comic-style, brain-teasing puzzle challenges from delightfully simple to deviously complex. To conquer all 61 challenges, you'll need to build bridges long enough to span the gap, tall enough to clear a sailboat, light enough to stay standing, and strong enough to hold a wind-up truck, even with a heavy load. If your bridge fails, no problem. Just reset it, strengthen it, and try again. Ready to build something amazing? Or will it be a bust?
All right, so that's the bridge game. And then as I said before, at the end of class, what I did with the kids was I showed them how the bridge game was made. And it's really fun. I think kids really do struggle to understand that everything around us was made by someone. And everything around us was probably catted out, multiple iterations of it, lots of prototyping, and then finally getting it prepared for manufacturing, getting it manufactured. It's a whole thing. So we also had the opportunity this year to visit our manufacturing facilities in Shanghai and Dongguan province in China. And it was amazing to be able to work directly with the engineers that are on site and see how things are done. We learned a lot. So this video is really fun to see because I have been to these facilities. And I'll just show part of it. Okay, so that's I'm going to show you of that. But I was amazed at how much the kids were able to draw connections and asking them, what did you notice? The amount of people involved in making things is astounding to them. And once, with the tariffs that impacted everybody this last season, we really tried hard to figure out how to get some of our manufacturing done stateside. And Paul was met with lots of different facilities here, and the ability to have people do things in the US is not as easy because of the way that our economy is set up. And so pretty much everybody that we talked to basically actually, we don't want to do your project because you have too much stuff done by hand. And almost all toys are actually made in China for that purpose, because first of all, they're excellent at injection molding, and they're also excellent at doing all of that handwork that's required on all of our stuffed toys and our other things like that. So anyway, I thought that was super interesting. So now I want to do a quick activity. So do you all have access to some sort of, I just want to do this for like 5 minutes. Do you guys have, oh, here we go. Somebody said, does the friction tension that keeps them from collapsing up to a point stay pretty consistent over time, or do they start to collapse? Okay, yep. Yes. So are you talking about, Richard, are you talking about the, are the bridge collapsible parts, like the magnetic portion of it? Is that right?
Yeah, whatever. I wasn't quite following exactly what it was that caused them to hold up to a point and then collapse. And I was imagining it was some sort of a set screw or something like that. And just, you had talked about how important it is that you can do the reproducibility, which you can't do with a toothpick bridge. But if that, whatever it is that's holding them from collapsing starts to weaken over time, then that reproducibility really isn't there. And then suddenly, if you're doing it as a competition, oh, Bob's group got the tight screws and Jane's group got the crappy screws. So Bob's going to win no matter what his design is, and Jane's is going to collapse immediately. So just trying to think about implementing it in a classroom, that piece, or is it that you have something that you can retighten them? I guess I wasn't quite catching that.
Yeah, it's actually magnets. So we don't have a problem with the reproducibility, but I will say this, we did have a problem with reproducibility when we were originally put them through to mass production. So when we put everything into mass production, it comes with like, 200-page book that we send to our manufacturer and say, make it like this, right? And then we get the parts back, and then they're not quite like that. And we found that they were using different magnets, slightly different magnets than what we had in our example set. And so we had our engineers, we have Paul, who is the primary engineer, and then we have 2 other engineers on our staff. And they went through extensive testing to see the reaction of the new magnets and to make sure that they were tuned correctly to the puzzles that we had already written. So it was like, we had certain puzzles that were written a certain way for a certain compressive force or a certain tensile force. And some of the puzzles we actually had to tweak a little bit in order to make it all like work.
Yeah, I ran into that. I did a curriculum for Reality Works, and when I have the prototype, and when the actual things came back from China, yeah, it was not what we had written the curriculum for. So I understand your problem there, but thanks.
Yeah, that's a great question. And these bridges have gotten a lot of use, and I will say that reproducibility is great right now. There's the amount of difference between when kids are building bridges. It's like there's not a difference. It's very different from doing the balsa wood situation. Okay, so one of the things that I wanted to say was drawing out the principles and learning targets. Okay, so let's say you have a great STEM toy, the kids are engaged with it, they're enjoying it, but you're trying to teach a certain thing. If you have access to some kind of AI, this is where I would say it really helps. So one of the prompts that I like to do with any kind of AI thing that I have is to give me questions that will get at what learning targets I wanted in the reflection from the students. So for example, if I'm going to take like the bridge or bust game, what I'm going to do is I'm going to say, I'm just going to give, I should have had this pre-typed, but I did have it typed and then I lost my chat because I wasn't logged in as myself. How many people have done that? So I'm going to just say my classroom of 4th graders is using bridge or bust to learn physics concepts about tensile and compressive forces. We are also learning the best geometric shapes to use, which is triangles, to use when building a sturdy bridge. What are 5 good questions, reflection questions, I can ask to make sure the students learned from the hands-on activity. So I'm going to do this. We're going to see what ChatGPT says to me at the end of this. So one of the things I like about this isn't that I'm going to just take the AI questions as they are, but it is going to get me going on thinking about how I might want to do it. And then I have in the past also had it where it will generate like a one-page printable worksheet. So I'm going to look at these questions and I'm going to say, do I like where they're going? So the ChatGPT is recommending which parts of your bridge were in compression and which parts were in tension. Now, that one I think is okay, except for that it would be really helpful to have that question while the kids have a bridge in front of them. And then one of the things I would show them is, which I do show them when I'm working with them, is that I can kind of feel where the wobbly bits are when I have a bridge built, and I would have the kids kind of feel around on their bridge that isn't complete and see where they're feeling that like wobbly piece and whether it feels like it's getting pushed together or pulled apart. So that was okay. What shape or pattern made your bridge the strongest? Why do you think that shape worked better than others? So we're trying to get these fourth graders to think about triangles. What happened when your bridge failed or bent? Now the bridge isn't going to bend, so I think just leaving it in failed would be good. My favorite question though is this: which part gave out first and what force was acting on it? This question is excellent because then where the kids are actually reflecting on a bridge that didn't work, what part of that gave out first? And I love this question. If you rebuilt your bridge, what would you change to make it stronger? And then I like this one. Where do you think engineers use these same ideas in real life? Can you think of a bridge or structure that might use the same forces? And with this question right here, I like that this makes me think about how I would with a class. I would take one of the students' bridges and I would say, okay, that's an arch bridge, or oh, that's a one-sided bridge, or whatever. And I would actually pull up some examples of that and have the kids look at it. I mentioned earlier that I really like picture books on bridges, and bridge information is readily available online with lots of pictures. So it's very easy to access it. And one of the things that I think, this also right here, this question, where do you think engineers use the same ideas in real life? One of the things to know about bridge building is that oftentimes every bridge really does use a combination of strategies to work. So the kids, we talked about the lift bridge in Duluth because lift bridge is the biggest one. And I'm going to ask you guys this question too. Why is the lift bridge built the way it is? Why does it have to lift up? Because of the iron ore tankers. Okay, so yes. So one of the things is that we have to be able to have it clear the thing going under it. Every bridge has to take into account what's going under it. The other thing it has to take into account is it has to take into account what is the surface that it's building into on either side. So in Washington State, they have a ton of floating bridges because the marshy underside of their of Washington Lake is so silty and loose that they would have to build pylons that were higher than the Space Needle in order to actually have them be sturdy enough to hold up a bridge. So they ended up making floating bridges, which you can't make with Bridge or Boss, but you can make every other kind of bridge. So you need to have something that goes under it. So with the lift bridge, it has to do that. Now, why didn't they just build the lift bridge so that it could go, the cars could just go up and over? Because that seems really inconvenient that all the cars have to stop for a tanker to go under. Okay, we have cost. Okay, let's also think about the cars having to go over it. Let's imagine a car having to go over a bridge that's tall enough to clear a tanker. And let's think about that space between Duluth and Superior, if you've been there recently. And how much space does it have for the for that arch. We also have ice. Yes, weather conditions are a big deal. Do you know how many bridges are impacted by high winds or coldness? They're built with different materials and in different ways because of that temperature. So I'm going to give you the answer for this one. If we were to build a bridge that could clear those big, huge container ships, it's going to be very hard for the cars to climb that incline. In Panama, they have an enormous bridge that does clear the container ships that are coming through every day, but it has miles of room from one side to the other. So it is able to go high enough in order to clear them. In Duluth, we have a small space between Duluth and Superior. The cars would have to go, it'd be like a roller coaster, in addition to the fact that we have inclement weather and it would be not safe for the cars to go over that way. So that is that. So that is bridge or bust. I love trying out AI and seeing how it works. It doesn't always work super. It definitely always, as you know, needs tuning and all of that. But it is, I think it's fun for the reflection piece. And the second thing I think AI is good for is cleaning up. So I use a system for my boys in the summertime where I have what I call a magic notebook for each of them. And it has a list of what they need to accomplish during the day. And the notebook retains its ability to have that like structure for them, because often they don't see me writing it. And secondly, it's always there waiting for them. AI is similar. So I also like using AI as a prompt. Like we just used this product to help us come up with a checklist for cleaning up our workspaces. And it kind of is like a third party saying, let's do this. And the kids kind of enjoy that. It's sort of a fun, it's like a game then when you're employing a different service. So now I have the giveaway link. Please click on that. And Melissa, also thank you for posting it. So if you want to do the giveaway form there, make sure your name is there, make sure your email is there. I will give you the choice, 3 of you. I will give you the choice of which game you want, and I will send it to you. And we have 5 minutes. I would love to hear from you. What kinds of questions do you have? What kinds of thoughts do you have? I haven't done this particular presentation before, so any feedback that you can help me do better, I would love that too. It's actually in the form asking you to tell me how to do better too, but if you want to share anything, I would love to hear it. And again, I'm really grateful for all of you taking the time to come out of your busy days. This was fun today. I was looking forward to it.
Looks like you've got somebody typing a question, a couple of questions. So.
Oh, great. Good. Awesome.
Yeah. And before we end, I just want to thank you, Alyssa, for the wonderful information, the engagement, the ideas, the concepts, really connecting the dots and bringing it full circle. So I just want to make sure I tell you thank you for everything that you did and sharing this information out. And it's really been great, very informative. So thank you.
Yeah, thank you, Jason. I'm really happy to be able to be a part of this. And I like helping Minnesota. So if anybody has anything that they have going on that you could use help with, teachers or resources or whatever, please don't hesitate to ask, because I really enjoy working with teachers. Right now, you guys, this is tax season, and being a CEO of a company versus being a teacher, this is where I don't enjoy it. So get me in the classroom. That's what I say. So I don't have to do more tax prep.
Ugh, ick.
Okay, thank you so much, Katie. Wondering if you discovered any kind of play that helps students in the classroom cross their midline. What's their midline? I'm also just checking the Google Forms to see if anybody had any questions too. Great. Okay, thank you, Richard. I don't think I said thank you to him before he already left. Oh, could you please repeat the email to request CEU documents? Oh, there it is. Good. Zachariah, I was gonna say that if you guys are ever open to somebody coming to watch your stuff you do with the solar things, I'd love to see it sometime. Do you do it in the cities, or are you based in southern Minnesota too? I feel like everybody's in southern Minnesota.
Our offices are at Minneapolis College, but we kind of go all around the state. Actually, I'm going to Battle Lake day after tomorrow.
Okay, Battle Lake.
And I'm really intrigued by the games that you shared. They're so cool. The bridge one is really sort of easy to understand how it would aid understanding. I feel like I would really need to spend some time with the touring game and with the spintronics.
Yeah.
For it to sort of sink in.
Yeah.
How it benefits understanding. But
yeah,
really cool creative stuff.
I have presentations that are geared for those specifically too. So, and I'm happy. I mean, it takes about even a half an hour of just walking through it. The bridge is the most obvious one.
Yeah.
Yeah. Yeah. All right. Well, thank you all. I really appreciated being here. Thank you for your time. This was fun.
Thank you so much.
Okay. Yeah. Thank you. Getting better opportunities. Okay. Yeah, that would be good. Thank you. And I'll look more up about the midline. Thanks, Tia.
There's your AI response in the midline.
Oh, here we go. Great. Oh, yeah. Oh, I forgot to do my code word.
Oh.
Can I do it now?
That's okay. I'll figure out something. I really like the code word idea. I'm going to use that one again, though.
I
really
had it
like
in my
that one.
notes and then I forgot. Dang it.
Yeah, that's okay. That's
Yeah.
all right. Well, at least I know, because if I were to send out and ask them for a code word, and they're going to be like, "What the heck? There was no code word."
There was no code word, and I listened so carefully 3 times.
I was involved the whole time. I swear it.
That's right.
Oh, shoot. Good. Well,
Right.
thank you, Alyssa.
Yeah, thanks, guys. Yeah.
I appreciate it, and we look forward to more partnerships, so other things that we might be able to do, and how we can support you in your efforts, and we really appreciate you supporting us in our efforts. So,
Yeah, great. Thank you, guys.
okay, thank you.
All right,
Have a great
day, guys. Bye.
All right, bye.